Try to read the question. If you can understand the question, you can manage. There are two situations are there. First, we'll understand. So one, I'll directly go for it. There's a block. I'll keep like this here. Now, first is applied. A force F1 is have to be applied along the line of fastest descent. Fastest descent means what happened? Along the incline is applying. So there's a force F1. Then what are the forces that will be acting? Mg sine theta, mu mg cos theta. Of course, normal reactions, all they'll be acting. If you want, you write it. So, and it is moved, constant speed is telling. So it is moved with a constant velocity. So what is F1? You can write it now. F1 equal to mg sine theta plus mu mg cos theta. Keep this equation 1 in hand. Next again, we have to drag the block down the plane with a constant speed. I'm going to drag it down. I'll apply force. So what are the forces that will act down the incline? Mg sine theta. And here it will be mu mg cos theta, normal contact, mg cos theta. So what should be the F2 should be equal to? F2 plus mg sine theta equal to mu mg cos theta. Mu mg cos theta minus mg sine theta. Keep this equation in hand, equation 2. Okay, next third case is asking. Find the minimum horizontal force F parallel to the plane required to slide the block. The diagram is what very important. So there's the inclined plane. This is the theta. Able to understand this one? So how is the block? the block is kept. Now is the force? Force is applied parallel to the plane. It's tangential to the inclined plane. It is the meaning here. So let's define the two directions here. And this one is parallel to incline. This is an inclined plane. Huh? So what I am showing this one, there's a line parallel to inclined plane it is. Okay, now what is this? This is an inclined plane where the okay, let's go for forces that are acting. Mg sine theta. Mg cos theta I cannot show. Will I agree? Mg sine theta I cannot show. Only F, applied force F, Mg sine theta I am able to tell that one. Okay, if you are still getting confusion, sir, like we are not understanding, I will write point P1, P2. What is that P1, P2? They are here. At least now, okay, fine. Okay, now listen. How the friction should act? Yeah, the direction of friction is very important. So the direction of friction will act at a certain this angle we don't know. I'll equate the forces now. F is equal to mu mg. Now, what is the friction force? First, we'll go for friction force. What about the friction? How to calculate here? Again, friction depends on normal contact. I am unable to show all the forces here, other forces here. So N equal to mg cos theta here also. In this problem also, N equal to mg cos theta. So therefore, what is the friction? Mu N equal to mu mg cos theta. Now let's write this direction. So this shall I call perpendicular to P1, P2? Perpendicular to P1, P2. What about this line? Parallel to P1, P2. Along parallel, perpendicular, equate the forces. So first equating forces along parallel. Along parallel. F should be equal to F cos phi. And this should be equal to mu mg cos theta cos phi. And then uh, along perpendicular, it is. No, along parallel, along parallel, along parallel, f cos phi, f sin phi is equal to mg sin theta. This is mu mg cos theta sin phi equal to mg sin theta. So these are the equations 1. So I'll call this is equation 3 and 4. Squaring and adding equation 3 and 4. Squaring and adding equation 3 and 4. 3 square. It's all about mathematics now. This will be f square plus mg sin theta whole square equal to mu mg cos theta cos phi whole square mu mg cos theta sin phi whole square. Okay, this quantity will become f square plus mg as it is. Let me write here this one. So this will become mu mg cos theta whole square. Okay, let's go for f square mg sin theta whole square. This I'll break up. I'll write it mu mg cos theta mu mg cos theta. Now what is 1 mu mg cos theta? From equation 1, what we can write? F minus mg sin theta. I'll write nearby from equation 1. Or you do one thing, call this equation 5, put 192 in 5. So then I'll end up this one. Then another mu mg cos theta, I can write it as f2 plus mg sin theta. Solving this, I'm leaving it to you. You'll end up with this answer. You do mathematics later on. Let me touch one more good numerical is there.
Sir, once can you go?
The third diagram is very important because again here that theta he should have given, it should have been easier. So since he explained, no, so he didn't give much help in the diagram. Okay, fine.
Okay, sir.
Okay, let's come for this one here. Read the question. So here,
So your voice is cracking.
Your voice is breaking.
Your voice is breaking.
Can you hear you,
like
sir? Sir, voice is breaking.
Sir, voice is breaking.
acceleration of
Not.
now okay, can you hear me?
Yes, sir.
I think it's clear. No, yeah. Okay, now look at the acceleration of the platform becomes 2 meters per second square. Oh.